Hi everyone, I hope you can hear me well. I want to thank you for joining the Endava DevOps Academy. Today is the first session, as you know. My name is Stevan, and today's session will be about introduction to DevOps, which will be held by our colleague, our DevOps consultant from Belgrade EU, Goran Vasic. Just before we begin, I want to put an important note that any questions you may have to ask to the presenter, to Goran, you will find the Slido access code on the slides that Goran will show. So please use that Slido access code to ask any questions during the session, since the last 15 minutes will be reserved exclusively for your questions. Also, there will be a recording of this session, and it will be available to you via Microsoft Stream. So I'm gonna take care of sharing the link with all of you once everything is in place. Okay, so without further ado, let's get into the training itself. I'm gonna hand over the stage now to Goran, and I wish you all a pleasant learning. Thank you.
Thank you, Stefan. So just before we start, I hope that you are able to hear me well and that you can see the initial slide. In case of any technical issues, please let Stefan or me know. So with that, hello everyone, and thank you for joining. As Stefan mentioned, today's presentation will be the first one in a series of presentations for the Endava DevOps Academy. So I have the honor to kickstart this great initiative. There will be many interesting presentations over the next several weeks. We have excellent and experienced presenters, so make sure to check your inbox regularly as Stefan will be sending out invitations. My goal for today is to introduce you to DevOps. I'm sure you already have a good understanding of that term, but you might have skipped over some of the important topics that are not mentioned very often, but that are essential for better understanding of DevOps. Also, as Devon mentioned, if you come up with any questions during the presentation, we have a Slido event code, so you will be able to ask your questions there. I will also display it on screen from time to time, so no need to pause the video at this moment. Also, I think you got it in the email invitation. We will have around 15 minutes at the end of the presentation reserved for discussion around those questions. This is the agenda for today. I will go briefly through the history of DevOps. We will see what are some of the influencing fields of study, as well as what are some of the core DevOps principles. And in the last section, we will go through some of the common steps for implementing DevOps in your organization. Before we start, allow me to say a couple of words about myself. For those of you who haven't met me before, my name is Goran Vasic. This year, at the beginning of August, I marked a milestone in my career, so I can now say that I have more than 10 years of experience. During my career, I've been working in various roles. I started out as a test automation engineer, where later on I got promoted to a team lead role. Then, due to major changes in that company, I began working on a different project where over the next couple of years, I worked as a full stack developer in .NET. When I finally started working for another company, my main responsibilities included writing frameworks for UI and performance testing, as well as setting up and configuring infrastructure for continuous delivery. I was also responsible for creating and maintaining the application installer for end users and for developing a client application that was used by the entire team for downloading artifacts and setting up and running local dev environment. Starting with that project, I shifted my focus towards Java platform, and since then I've been working mostly with Java. I joined Endava in early 2016 as a consultant on a long-term Adobe project that deals with automated provisioning of infrastructure in cloud, specifically using AWS and Azure services. So by working in different roles and by participating in various stages of a project, I gained really valuable experience, which now helps me to better understand how things operate on a higher level, but I also got the hands-on experience at the lowest possible level. When talking about my career, I like to say that I'm just starting, as I consider myself to be a continuous learner. Software development is a huge field of computer science, and there are so many things we still have to learn. So you all know how many new tools and frameworks and concepts we hear about each year. So there is always something new to learn or to try out. In fact, that serves me as a good introduction because we are often unaware of certain changes or novelties in the industry that are affecting pretty much everyone around us. Some of the obvious examples include Docker and Kubernetes, or the shift towards using cloud services or serverless computing. You perhaps ignored these things initially, but I'm sure that one day you just started hearing those buzzwords wherever you go, and that is pretty much the same way we have all heard about DevOps, as it is being mentioned a lot lately, and that is one of the reasons why we are talking about it today. For those of you who are more than 2 or 3 years in the industry and that have a LinkedIn profile with word DevOps in your title, I'm almost certain that you've noticed an increase in job offers coming from IT recruiters in the last couple of years. That actually goes along with the results of a research performed by LinkedIn, which states that DevOps engineer was one of the most frequently searched job role amongst IT recruiters and the overall most recruited job of 2019. So DevOps is in a way still a buzzword. But while there are companies that are currently in the process of discovering DevOps, most, if not all, of the major players in the industry have already adopted it. The benefits are often visible almost instantly, and stories about success quickly spread across the community. So it's no longer a question if DevOps works. We have seen many examples and heard many success stories. The important questions these days are how to actually implement DevOps and who can implement it. That explains the increased demand for DevOps engineers I mentioned earlier, as companies keep hiring those kind of engineers to solve their problems. But job title DevOps engineer might be a bit misleading. You can easily find several presentations on the internet which are explaining why DevOps should not be considered a job role, and I'm also a proponent of that. If you're interested more in that topic, we had a great presentation during this year's AM week. It was held by my colleague Stevan Cvetkovic. You can find the slides and even the recording on Endava Confluence, so I suggest that you check that out. But if we put that aside for a moment, most of the times when we say DevOps engineer, we are thinking of a person who will be responsible for implementing a continuous integration or continuous delivery pipeline on our project, or someone who knows Kubernetes or Ansible or Terraform and is experienced enough to work on virtualization tasks or cloud infrastructure or networking tasks, and possesses these specific type of skills. This definitely describes DevOps engineers well, but if you think about it, it seems like at one point of time we simply stopped hiring IT infrastructure or networking engineers or Linux administrators. We are now specifically searching for DevOps engineers for our project, as only they can get the job done. It is like there is a new kind of software engineers called DevOps. But is that really the case? I mean, is it really true that only a DevOps engineer can get the job done? What even makes a DevOps engineer, and how do you even become one? Well, let's first try to define what DevOps is. One of the often quoted definitions comes from Adam Jacob, who is a co-founder of a company called Chef. They're known for their configuration management and infrastructure automation tool with the same name. So he says that DevOps is a cultural and professional movement. Similar to this, the definition from the book Effective DevOps says that DevOps is the journey and not the destination. Another one comes from one of the leaders in the DevOps movement and co-author of the famous DevOps handbook, John Willis, who says that no one can tell you what DevOps is, but you'll know it when you see it work. So I'm sure that you are already noticing that these definitions are not really telling us much, and they are pretty different from what we've said so far and what we usually think about when we say DevOps. Notice that they are not even mentioning CI/CD or automation. So maybe a better idea would be to see how Wikipedia defines DevOps. After all, that is the most often the first place we start when we are doing some research. So according to Wikipedia, DevOps is a set of practices that combines software development, or dev, and IT operations, which is commonly referred to as ops, with an aim to shorten the system's development life cycle and provide continuous delivery with high software quality. So, in other words, by Wikipedia, DevOps engineer would be a person who implements a certain set of practices that would bring dev and ops closer together, with the main goal of speeding up software development processes with a strong emphasis on maintaining high software quality. And someone who is responsible for implementing continuous delivery process. So this definition sounds more familiar. We are combining dev and ops. We also have continuous delivery being mentioned, but this is still different from the previous definitions, especially the ones that are defining DevOps as a journey or a movement. So what is the correct definition then? Well, an interesting thing about the Wikipedia definition is that if you scroll down a bit, you will see a sentence that states that academics and practitioners have not yet developed a unique definition for the term DevOps. But at least we can all agree that DevOps is all about breaking down silos between dev and ops teams and bringing those two together. I mean, after all, those terms are in its name, so that part must be true. Well, lately you might have heard or stumbled upon the term DevSecOps. There is as well, there is actually a well-known software company called Puppet Labs that have been releasing annual reports since 2012 under the name the State of DevOps Report. Behind each of the annual reports is an extensive research, and in 2019 they have put an emphasis on the so-called DevSecOps, where they explained how important it is to include the security team into the software creation process and to find and fix security vulnerabilities before releasing your application into production. Interestingly enough, in the same report, they are also saying that they do not especially like the term DevSecOps. Their opinion is that we could use the term if that is what it takes to involve the security team, but they are also raising the question of what comes next. Should we also include the QA team in the official name? Testers are, in my opinion, already an integral part of the dev team, but they are often in practice considered to be a completely separate silo. The same applies to the monitoring team and so on. So if we go down that road, we might end up with the terms such as DevSec, QA, MonOps, or something along those lines, which would no longer sound that catchy. But the real question is, will having a different name actually solve the problems we are dealing with? Since there is no official definition of the term DevOps, perhaps it would be a better idea to define what DevOps is not. So as we've already seen, even the Wikipedia definition defines DevOps as a set of practices. So I think we can safely say that it is not a title or a person. Also, if you think about it, let's say that you have a backend developer in your team and she starts working according to these practices and learns how to install and configure Jenkins or how to use Docker and Kubernetes. Does that mean that she's slowly shifting from a backend developer position to a DevOps engineer role? Is she crossing a line somewhere? Also, if you don't allow even a highly skilled automation tester who knows how to program to fix a bug and commit to your code repository, then essentially you are preventing him from contributing to your project, and you are slowing down the entire process, all just because he's not a dev. And the same applies to the so-called DevOps team. So if they are the only ones who can run a CI pipeline, then they are sitting in another silo. Naming them DevOps engineers is even counterproductive because it separates them from the rest of the team. Also, DevOps is not a tool or a product. There is no such thing as a DevOps tool, even though we often think so. There are various specialized tools in software development that can be used for accomplishing different tasks. And I'm sure that you could name 20 of them right now, but even some of the most famous DevOps tools existed long before we started using the term DevOps. And even tools such as Jenkins are not being promoted as DevOps tools. On their official website, it says that Jenkins is an open source automation server, which it is. If you say that Jenkins is a DevOps tool, then you must agree that Maven is also a DevOps tool, and Git and so on. So these are just specialized tools that get a specific job done. Also, as we've seen, DevOps does not mean only Dev and Ops. We've already mentioned that there are other roles and teams involved. Again, one of the main ideas is to break down the silos, not to create yet another one by introducing DevOps team and raising the walls between them and the rest of the team. DevOps sounds catchy, but the problem with that term is that it mentions only Dev and Ops and leaves all of the others aside. So with all these questions being raised and points being made, let's first see how we even ended up with the term DevOps and who coined it and when. So Patrick Dubois is an IT consultant who is primarily known as the founder of the annual DevOps Days conference that is being organized since October 2009, when the first one was held in Ghent in Belgium. Patrick is considered by many as the godfather of DevOps, as he practically popularized the term when the visitors of the DevOps Days conference started using the DevOps hashtag on Twitter. Interestingly, his first pick for the name was Agile System Administration, but DevOps turned out to be more convenient and catchier. So how did Patrick then come up with the term DevOps? Well, the timeline goes like this. So in 2007, While he was working as a sysadmin for the Belgian government, Patrick got frustrated because of the constant conflicts between developers and system administrators. He was trying to think of a better way for those two teams to cooperate. In August 2008, on the Agile conference in Toronto, Andrew Schaefer announced that he will be holding a Birds of a Feather session under the name Agile Infrastructure. For those who do not know, Birds of a Feather session is an informal meeting on conferences where the participants gather to discuss about some predetermined agenda. On that particular Birds of a Feather session, there were exactly two attendees. First one was Andrew Schaefer, who organized the session, and the second one was Patrick Debois. So logically, Andrew decided to cancel the session, but Patrick found him in a hall, and they started having a conversation. As a result of that, they formed a so-called Agile Systems Administration Group. So fast forward to June 2009, when John Allspa and Paul Hammond held a now famous presentation under the name 10 plus deploys per day, Dev and Ops Cooperation at Flickr. Patrick Debois was not able to attend the conference, and he was watching it online. He was truly excited when he heard what these two were talking about, and he complained over Twitter that he's sad because he could not be there in person. One of the replies mentioned that he could bring them over by organizing a conference in Belgium, which he eventually did the same year. While organizing the conference, he needed a name. So he got the inspiration from one of the slides where Dev and Ops were written in a heart symbol. Eventually, the conference turned out to be a great success with large number of visitors, including developers, system administrators, and software engineers of various profiles. And as I already mentioned, the term later on spread over Twitter, and the hashtag DevOps became the official term under which people could finally search for the material on this specific topic. So with that, you might think that John Allspa and Paul Hammond were the original creators of DevOps, but they used a different term in their presentation. They used Agile Infrastructure. And if you recall, the Birds of a Feather session I mentioned earlier had the same name. So that was already something that existed even before their presentation. So to understand how Agile Infrastructure, or now DevOps, came to be, it is best to go over the various influencing fields of study, as DevOps is the direct result of applying these principles and practices from industrial manufacturing onto IT. John Willis, the author of one of the definitions we saw at the initial slides, calls this the convergence of DevOps. So DevOps, or Agile Infrastructure, obviously has its roots in Agile software development. If you think about it, even this picture looks like something we usually draw when we want to explain CI/CD. Agile software development also shares one bad characteristic with DevOps, and that is its name. We all like to call it Agile as a noun and with a capital letter because it is nice and short. So we now have terms like an Agile software developer, in a sense that he's an Agile person, or Agile community, as if you have a group of people that can move very quickly from one place to another. The focus was always on the software development part of its name, but now you have some companies that are selling you Agile trainings where they let you play with Legos and marshmallows, but when you ask them how to apply that to your project, they usually say, well, it's your job to figure that out. So even though we are all practicing it, we often find ourselves struggling with that software development part. For more info on that, I suggest that you watch a presentation by Dave Thomas called Agile is Dead. I think there is not much that needs to be said about Agile software development. Again, I'm pretty much certain that we're all practicing it. It became popular around the time when startups and the open source community started pushing the whole industry forward, and it is now a de facto standard way of working. In terms of DevOps, it took the iterative approach that focuses on collaboration, instant feedback, and small rapid releases, as well as embracing constant changes. The second field of study is operations management, or OM, which includes various practices that ensure the highest level of efficiency in an organization. The main goal of operations management is to convert raw materials into a product or a service in the most efficient way possible. That way, a company ensures that it will get the maximum profit, maximum amount of profit at the end. There are several things that fall under the operations management, one of those being systems thinking and dynamics. It is a holistic approach to analysis, and it focuses on the way a certain system functions as a whole and when it is a part of a larger system. It includes creation of experiment plans and scenarios for finding out how a system behaves in certain situations. Then running simulations and the analysis of the output data, and also how to change a system so that you modify its behavior permanently. It is a really complex topic, and it is often being applied in economic or medical researches. Then we have the theory of constraints, which is all about finding a bottleneck and addressing it so that you do not have an interruption in your flow. In other words, every organization must have at least one constraint, or the weakest link in the chain, and you should be able to improve the overall throughput by removing or improving that constraint. It sees the entire system as a whole and says that you should always optimize globally, because if you focus too much on one specific part and try to optimize locally where you don't even have a problem, then that can produce a negative result, because you could flood everyone downstream and create a new bottleneck. In a book called The Phoenix Project, actually it's a novel, there is an example of how the most productive team members can become the bottleneck. Lean is an American name for TPS, or Toyota Production System. TPS is often given as a main example of the Kaizen approach, which is essentially about continuous improvement in small iterations. The main goal of Lean is to improve the production, and it is all about working in small batches with a small number of resources, but with high flexibility and with the highest possible product quality. With the oil crisis in 1973, the price of oil went really high, up to 4 times higher than before, but the American auto industry continued producing large vehicles that also had high fuel consumption, because they were unable to start doing something else. As a result of that, Ford, General Motors, and others ended up having a lot of big cars sitting on the dealer lots, and they were unable to sell them. On the other hand, Japan was devastated after the World War II, and their industry had to reinvent the way they were working. So when the oil crisis happened, they were able to stop the production line, to shift their focus, and then to continue with full speed after the crisis was over. Their cars were then looking good as they were much smaller when compared to the ones that were being produced in US. So that suddenly made Japan a huge competitor on the market. I would also like to point out that this is where the Endon system comes from, which is a system for notifying everyone involved about various quality or processing problems. In terms of DevOps, I think that this picture might remind you of some software you're using on your project. As for the actual name for the system, Endon is a Japanese word for a paper lantern. Also, we have a lean management method called value stream mapping, which is used as a visual tool for displaying critical steps and processes in a production system. Value stream map shows the flow of both materials and information as they make progress through the entire process. Its main purpose is to identify and remove or reduce waste in order to increase efficiency. And it is interesting that by waste, Japanese are also thinking about waiting, where waiting for all prerequisites so that you can start your work is slowing down the entire process. I will also mention IT service management, or specifically IT infrastructure library, or ITIL for short. So the core concept of ITSM is the belief that IT should be delivered as a service. ITSM includes all activities such as policies, processes, and procedures that an organization should perform in order to design and to plan and deliver IT services to its customers. It is a large field of study, and it mentions a lot of ISO standards and such things, so I really cannot tell you anything interesting about it. ITIL is a set of guidelines for managing IT services, which covers best practices and proven techniques for managing incidents or changes on an IT project. So just be aware that DevOps is also learning from ITIL and picking and integrating the best methods from this discipline. So as you can see, DevOps is a combination of various cultural philosophies, practices, and tools, and not something that came into existence out of nowhere and overnight. And it is more than just CI/CD or automation. It is a cultural and professional movement and way of working. So with that, let's at the end see how Endava defines DevOps. On DevOps Endava.com, you can see that we are defining it as a way of working where cross-functional teams are delivering and operating software systems with a goal of achieving a visible, measurable flow of value in a continuous and sustainable way. So that pretty much sums up everything we've been talking about so far. And Endava strongly believes that DevOps is achieved only when all of these components work together to modernize the software development lifecycle. That includes cloud, best practices in software architecture, test automation, continuous delivery, application management, and so on. I would strongly suggest that you take a look at our conference page and to read the information there, and perhaps to even start contributing, why not. So we also have a lot of great materials on Endava Conference under continuous delivery practice and under cloud space, so make sure to check that if you are interested. So I hope that we have learned by now that DevOps is a way of working that encourages collaboration and that learns from various disciplines and implements the best practices in software development. I suggest that we now go over some of the core principles of DevOps. Any discussion about DevOps requires an understanding of the so-called three ways. The first way, or left to right flow, it is about understanding the entire process from left to right, or from dev team towards the end users. Focus is on continuous delivery and increased speed. This is where systems thinking comes into play, as you must understand your entire system and how a feature travels from the start until the end. Emphasis is also on finding bottlenecks and making the entire process visible. You should never pass a defect downstream and never allow a local optimization to cause global degradation. The second way, or right to left flow, is all about the feedback loops. You should understand the needs of your users, or better, the needs of the next one that comes in the chain after you. By listening and asking for feedback, you will know how to better optimize the entire process. And the third way is about creating a high trust culture, about developing healthy habits that are good for the team and for the entire project. Also, the emphasis is on continuous improvement and experimentation, learning. If you trust your coworkers and if you know that you can make a mistake and not be blamed for it, you will become more productive and will more likely suggest and try to improve something on your project. Besides these three ways, there are certain principles which ensure positive outcomes in software development, and they are often referred to using the abbreviation CAMS. So they are culture, automation, measurement, and sharing. Culture means that people and process should always be in the first place. If you do not have a blameless culture in your organization, you will lose time and energy discussing who did this and that instead of focusing on what really matters and trying to resolve a problem which is in the best interest of all team members. As we all know, automation is one of the most important aspects of DevOps. This includes automating everything that makes sense being automated. So instead of writing and maintaining long wiki pages with instructions on how to set up your local environment, just try to write a script for that. Nothing prevents you from writing comments in there, and the script can then serve as your documentation. Because if the script doesn't work, then the documentation is obviously outdated. And what's nice about this is that you can quickly bring new team members up to speed, and they can immediately start contributing to your project by updating the script if they encounter any issues. There is an abundance of tools and technologies that can be used for automation. They all have their benefits and flaws, so this is where it gets important that you understand the purpose of these tools and have someone in your team who is experienced in using the tools that are right for your project. Again, that doesn't have to be a DevOps engineer, it simply needs to be an engineer from your team, so no need to focus on the job title. Of course, the advantage of so-called DevOps engineers is that we are all aware of these tools and have them on our radar, so we must know how to use them in order to do our jobs, but that doesn't mean that that it is forbidden for any dev or QA to learn how to install, configure, or use Docker, Ansible, or Kubernetes, or how to provision an instance in cloud and configure monitoring. And while we are at monitoring, you should define relevant metrics for your system and analyze the results, as they will tell you if you are on track. This includes measuring performance of your application as well as the internal processes such as team velocity and so on. Last but not least, sharing is also important, as it is critical to have a culture in your team where people can share their knowledge, ideas and information as well as concerns. Sharing can also mean spreading the word outside of your team boundaries over a beer with your friends from another team or company. These stories drive constructive discussion, exchange of ideas, and motivate others to start thinking about what can be improved on their project and how they could implement those practices themselves. That is how DevOps became a buzzword in the first place. So knowing all this, let's see why would we even want to practice DevOps and how to implement it. I mentioned the state of DevOps report by Puppet Labs. So we already have results from years of serious research and surveys on DevOps, and so far we did not see any company that says that it would like to go back from DevOps to the old way they were working. In another survey sponsored by Google Cloud in late 2018, the results showed that about 2/3 of surveyed companies that started practicing DevOps see clear benefits that affect their businesses. Regardless of their size and how many employees they have, all companies have reported that their teams are now in much better shape, that they have less problems in production, and that they can fix bugs in less time than before. Also, they are overall responding much quicker to any market changes. So to summarize why any company should consider implementing DevOps, DevOps is all about bringing the latest software changes to end users fast and frequently with high quality in mind. So this is all about optimizing software development process. The speed it brings boosts user satisfaction. Also, internal members are getting more, let's say, getting more it beats the competitions and helps you save a great amount of time and money on fixing problems when they occur. DevOps enables delivering software releases in an automated and continuous manner with a click of a button. So through continuous integration, continuous delivery, and continuous deployment, you're getting a fully automated and transparent pipeline for all of your changes and your work. It becomes much easier to spot a problem in your process and to fix it, and the overall stress level for your team members is drastically lower when compared to having only manual process in place with a lot of documentation. You all know about the never deploy on Friday rule. Well, if you constantly integrate your changes and build and deploy your project on a daily basis, and if you have meaningful unit tests in place, then and also if you deployed your application so many times that you are considering switching to continuous deployment now, then there is really no reason why you shouldn't do it on Friday. It then comes down to just another click of a button. So let's say that you have a manager role and that you wish to implement DevOps on your project. Where would you start? Well, first, the whole team should agree on a shared goal. Try to find bottlenecks in your project, think about what is painful to do and where are your team members wasting most of their time. Then see what can be optimized and improved. You must ensure approval from the upper management as well. So it is really important to create a clear vision of where you want to be or what you want to achieve so that you can present it to your team and anyone else. Also, try to define short-term milestones. Always start with small steps first so that you can very quickly get a sense of how difficult the whole endeavor will be and if you need to adjust anything in your plan along the way. Second one is you should create a Scrum team that will be focused on tackling these milestones. Everyone in that team should be working on the same problem and make sure to put only seniors in that team. Do not think in terms of job roles, but make sure to allocate the right people with the right skills. You should be honest when telling them what needs to be done. It is crucial that this team becomes successful as they will most likely spread the word and become a role model for the rest of the team. Also, it is very important that you do not interfere with their work or to change their priorities again. You want them to succeed. Third one, automation is basically one of the basic principles of DevOps, so automate everything you can. At this point, you should already have at least continuous integration in place. The software tools you use have a huge impact on your project, so try to find the best solution for fully automating your deployments and for making the continuous delivery process seamless. Achieve short-term milestones and measure progress. The first milestone can be having a local development environment being fully configured for all of your team members using the same script. Second one could be having continuous integration in place, and the third one then making sure that the script can configure your application across all environments. Either way, make sure that you are measuring your progress along the way. You are setting your own milestones, so just make sure that you are staying on the right track. Celebrate success. You should show others what you have accomplished and how far you have come. You will be surprised how quickly others will start adopting the same set of practices. Culture in your team actually should remain a top priority at all times. It is even more important than automation. So always try to encourage communication, cooperation, knowledge sharing, and mutual respect among your team members. Try to reward success, but do not blame others when they do something wrong. It is very unlikely that your team members do anything wrong on purpose. So make sure to have a constructive discussion about what can be done so that the situation doesn't happen again. Try to learn something new from that and think in terms of improving, not punishing, actually. Also, if you are thinking about how can you experiment if you are overwhelmed with tasks, well, you can do that by reserving 20% of the time in your sprint to experiment or to pay off technical debt. In the long run, this is never a bad decision. But managers are often afraid of taking that first step as it seems like they are losing time. This brings us to the last step. DevOps is not a destination, but a journey. Always try to improve your existing process. A nice way to figure out what needs to be improved is to imagine that you have lost all of your code and that you have to write your application from scratch. So ask yourself, what would I do differently? If you are unable to answer that question, then you are either working on a perfect project or your project is doomed. At the end, let's go over some of the recommended readings that could provide you with more details on the topics we've covered during this presentation. First one is the Phoenix Project by Jin Kim, which is a novel that tells a story about a company that is struggling with bad practices and which follows a person who becomes an IT manager and is given a short deadline to solve a seemingly impossible problem. Through multiple discussions with a certain board member, he slowly realizes how similar IT work is to the work that is being done in a manufacturing plant. And he then starts improving the process and solving specific problems by applying the lessons learned. It is an interesting novel which doesn't require any technical knowledge from your side, but it clearly explains a lot of problems we are dealing with in the IT industry. Next one is the DevOps Handbook, which can be considered as an unofficial sequel to the Phoenix Project, as it explains all of the events from the novel from technical perspective and pretty much covers all of the topics that have been mentioned today, but in much greater detail. So I would highly recommend these two books to anyone who is starting to learn about DevOps. The third book is Continuous Delivery by Dave Farley and Jez Humble. Romanian colleagues might know Dave Farley as he was in Endava, I think in 2016 in Cluj. This book covers all of the principles and technical practices that enable rapid and incremental delivery of high quality software to the end users. It is a must-read for anyone who would like to know more about continuous integration, continuous delivery, and about best practices for releasing your software into production. So at the end, I would like to thank you all for joining in. I hope that you have learned something new today. DevOps is a huge topic, and this presentation was meant to provide you with a nice foundation so that you can now continue learning and researching on your own. So we still have some time left, so I suppose we can now go over the questions. Okay, so just let me try to share the Okay, so I hope that you can now see the questions. I don't know, Stevan, if you can just confirm.
Yeah, I think it's visible to everyone. I can see the questions.
Okay. Okay, so let's start from the top. How can we help our clients to implement DevOps in the projects we're working on? Well, basically I already mentioned something similar. You need to start by forming a Scrum team that will drive these changes. So Most often, these are really small steps. You will be surprised how these small things can start the whole process. For example, the one I mentioned for automating the local development environment. Basically, when you get this script to all of the team members, and when they confirm that they can configure and install and configure their local development environment using this script, then after that it is really simple to start thinking in terms of continuous integration, actually continuous delivery, because then this script can be also used for configuring your environments, and one thing drives another basically. So again, for your clients, just start first seeing what can be improved, what are the biggest bottlenecks, where you're losing time, and try to figure out what can be improved. So you will definitely be surprised how quickly it will start to grow from there. And I also think that most clients will welcome these changes. When they see positive outcomes, they will definitely give you more freedom to implement these practices or whatever. Can Agile and DevOps work together, or are they mutually exclusive? No, they are not mutually exclusive. Basically, as we saw, DevOps learns from Agile and applies a lot of things from Agile. So this is not something that excludes everything that Agile has to offer. So they definitely can go along. How long it takes to implement DevOps initially? Well, it depends. Again, it depends on the that end goal that you're trying to achieve. So you might be in a different stage of maturity when compared to some other team or maybe company even. So it really depends. There is not one measure that fits all. So usually in let's say couple of months you can already have again this continuous integration or a lot of these things automated. So it again really depends on also the software architecture you have on your project and so on. So as for the culture in your team, this is something that cannot be done overnight. You really have to be actually this comes from managers. This comes from top to the bottom, basically how your team behaves and what are the practices in your team. Are they sharing knowledge and so on? So it's again a process, and it's not something that is a goal where you say, okay, we now have DevOps. It is the emphasis again is on continuous improvement. So it is a never-ending process, basically. Is a site reliability engineer role created by Google and widely adopted by the companies related with DevOps movement somehow? Again, I would really not label anyone as a DevOps engineer or basically you have we are all software engineers. That's the bottom line, basically. So we all have various skills, and we know how to do different things. So we should not simply draw a line between certain roles and say that because that's basically creating a silo. And DevOps again is all about bringing these silos down. So thank you. So just. Okay, so yeah, again, I think that when thinking about roles, we should all stop thinking about roles and basically try to, as Endava says, be the best we can be. And nothing prevents you from learning new tools or implementing best practices. And we all, of course, have different tasks on our projects. But for example, I'm working for Adobe. They have a so-called unified engineer. role. Well, where basically they're deleting all of the lines between different roles. So unified engineer is just someone who knows how to get the job done. What a good DevOps engineer needs to know to be able to work efficiently on such position. Well, I already mentioned, again, I would not call it a DevOps engineer, but you need to know a lot of things, because there was like a big bang when we all started moving towards cloud, and just an explosion of various tools and technologies and so on. So you simply, if you think in those terms, you simply need to know the tools that are being applied and used on your project. So as I said, there is no such thing as a DevOps engineer, and also not an engineer who knows everything. You should just try to learn as much as possible so that you can basically become a senior and can contribute to that project. Does DevOps engineer needs to be experienced or junior? That is the let's say a biggest problem, at least I see, where we are hiring junior engineers, calling them junior DevOps engineers, and somehow hoping and thinking that they can then start implementing best practices and so on, where they don't even have a clear picture in their head what a continuous integration or continuous delivery is. So often when I'm doing interviews, we are getting these junior DevOps engineers that really do not know even much about DevOps. So it is, again, something that we are all aware is happening. We are going along with the industry, but I really don't think that it is a good thing. Basically, all of these junior engineers will learn how to get the job done, but we are suddenly adding them to certain projects and expecting that they contribute. So I don't see that as a good practice. I think I covered most of the, if not all of the questions. So yeah, I think that would be all. So again, thank you all for joining. I honestly hope that you learned something new today or heard something new. So again, this is meant to be just a foundation for you. So if you're interested more in those topics and in DevOps, just first try visiting our conference page, and later on try reading these books I recommended. So from that point onwards, I think you will start figuring out what needs to be learned next. So with that, I think Stefan, maybe we can end today's session.
Yep, thank you, Goran. Thank you, everyone, for attending today's session, and wish you all the best.
Thank you. Have a great day.